Welcome to Brain Vision.
For this problem, we are given the scenario where there's a 1.2 kilogram block sliding on a horizontal surface with a horizontal spring attached. And the spring has a spring constant of 480 newtons per meter. At time t equals 0, the block passes through x equals 0 with a speed of 5.2 meters per second in the positive direction. And we're being asked to find what is the frequency, the amplitude of the block, and to write an expression for x as a function of time. So for the first part, finding the frequency, we're going to use the equation frequency equals 1/2 the square root of the spring constant over the mass. And so plugging in our values, we have 1/2 the square root of 480 newtons per meter divided by 1.2 kilograms, which gives us a frequency of 3.2 hertz. So our frequency here is 3.2 hertz. Now, for the next part, we're trying to find what our amplitude is, our xm. And we can use the equation x equals xm cosine of omega t plus phi. And in this case, x equals 0. And t also equals 0, because we were told that at time 0, the displacement was 0, passed through position 0. And so we can rearrange this equation in order to solve for phi. So we want to solve for phi here. So rearranging the equation, we get that 0 equals amplitude times cosine of phi. And again, solving for phi, so we would divide by xm, which would be 0, and the reverse cosine of 0 equals phi, which means that phi equals pi over 2. Now that we have phi, we can use the velocity equation, where velocity equals omega times amplitude sine of omega t plus phi. Velocity we have is 5.2 meters per second. And for omega, we can solve for omega, where omega equals the square root of k over m, which equals the square root of 480 divided by 1.2, because we had our mass and we were given the spring constant of 480. So that means omega equals 20 rads. So we can plug that in. So we have 5.2 equals 20 times our xm sine of phi, because again our time is 0. And solving for amplitude here, we know that phi, we can actually substitute out phi for pi divided by 2. And if we solve for our xm, we get that xm equals 0.26 meters. So that is our position at 0.26 meters. That's going to be our position, or our amplitude for our oscillation. And then the last thing we're asked to do is to write this in terms of time. So we have x equals 0.26 cosine of 20 times t minus pi over 2. And that would be our expression.